Hello everyone, Professor Dustin here, and this video is going to be a short introduction to definite and indefinite integration on the SAGE system. So first, as a quick overview, SAGE, you can get it at sagemath.org, is a free and open source computer algebra integration numerical analysis program. I'm going to use Sage Math Cell that's running in a browser on a server somewhere. It's a little bit slower. You'll see the responses are not that quick, but it's just incredibly easy to get started with Sage using Sage Math Cell. CoCalc is like a shareable cloud worksheet. I actually don't know very much about that. And then you can also download Sage. And really, if you want to get serious, you really want to download it so once locally on your machine. You can do all the sort of great stuff. It's quick, all that kind of stuff. Just all these sort of like little introduction to Sage things I'm getting from this guy named Gregory Bard. I forget where he's a professor of mathematics at. His website is kind of funny because he's preserving the look and feel of the World War Math as it was in 1998. So it's just kind of like a very ancient looking website. Lots of cool stuff here, including some LaTeX help, which is nice. But he has a whole book for Sage, which is you can download the black and white or the color PDF version of it. I have a hard copy. The hard copy is pretty cheap. It's kind of a nice text, so I would recommend getting it if you want to know more about Sage. The thing that's kind of annoying about it is it doesn't have an index, so somebody else created an index, but of course, like it'd be nice if the index was actually in the book, whatever, it's free. Anyway, so that's where a lot of the examples that I'm going to show you are coming from. So let's try this right from the get-go. Let's go to Sage Math Cell and ask it to integrate something. So Sage is incredibly easy to use. I just type integral, and let's do something that like I wouldn't necessarily be able to do off the top of my head, x sine x squared, and then you have to say comma x. That's saying Sage integrate over the variable x, and then you can either click evaluate or you can hold shift and push enter. I do the shift enter thing. That's from using Sage on my desktop, I have it installed, and so that's sort of a common way of evaluating cells in Sage. And then it spits it out minus 1/2 cosine x squared. We can check that that's right because you take the derivative of cosine, you get sine. That x squared then pops out to be 2x. Sorry, cosine is minus sine, and that's why the minus sign comes from. Okay, cool. So first, before going on, everyone's probably aware of the other sort of famous free mathematical analysis software, which is Wolfram. So Wolfram, in some ways, is smarter than Sage, and in other ways, is dumber than Sage. So one way in which it's much smarter is that it understands human language better than Sage does. So for instance, if I told Sage, integrate that thing, and let's say I got rid of the parentheses or something, and said, hey man, do that thing, it will fail because Sage really depends on the syntax that you put in. It doesn't understand if there's no parentheses here or what the word integrate means. It only knows what the word integral means. If I go over to Wolfram and I just say integrate that thing over that variable, and I haven't tried this, but usually Wolfram can figure it out as long as it's reasonably. Yeah, see, Wolfram said, oh, I know what you mean. You mean this specific command, which really looks exactly like the one in Sage that gets passed to the real Wolfram server, and it popped it out totally fine. So, and you could probably do other things to this. Like you could probably get rid of that, integrate this. Here, this might not work. Maybe Wolfram is not this smart, but we'll see if it's that smart. Yeah, see, they interpreted that as this, and then it actually didn't do the integral. So there is another interpretation. Maybe I could do this. Okay, so now it's telling us the things that it can do, options, right? That's more than Sage did. Sage said, no, I don't know what you mean. So we have to keep that in mind when we talk about doing Wolfram versus Sage. Wolfram understands human language better, but Wolfram stops functionality pretty quickly because there's a paid version of Wolfram. It's called Mathematica, and it's massively expensive. Sage has no paywall. Sage just goes. So anyway, let's try a couple other things. Let's try something else. Let's try like x over x squared plus 1, and let's do that x on x again to make sure that we can do a couple of different kinds of integrals. Cool. Okay, now notice the other thing that happened when I integrate on Sage, I get this answer, which is the same answer that I got over here. Remember, that was the answer from before, but Wolfram also says plus constant. So remember, when you do indefinite integrals without limits, you get this constant added to the answer, because when you take the derivative, the integral is supposed to be the opposite of the derivative. If you take the derivative of this term, you get this thing, the derivative of this thing becomes that, but you can always add a constant to an integral, because when you take the derivative of a constant, it goes away. Sage doesn't give you the constant, doesn't say plus constant. That's basically because of some details in the Python language. It's hard to specify things that are unknown, apparently. I don't know enough about Python, why that's the reason, but it is true. So we have to be careful with Sage that there actually is a constant at the end of all of our integrations. We want to do indefinite integrals. Sorry, we want to do definite integrals in a moment. But first, let's make sure we can do parameters. So like in physics, we often have parameters in our integral. Masses, positions, times, like some things we may not be integrating over. So first, let's make sure that we can do that. You would want this to work. Well, so let's say I have like m, right? Let's say I have a mass of an object and that the actual integral I want is x over x times m squared plus 1. I want to integrate on x. Let's try that. And actually, no, Sage says, ooh, m is not defined. I know what x is. X is like a variable, but I don't know what m is. So we just have to remember how to define variables in Sage. We have to do var m. This is part of the flexibility of Sage, is that it doesn't know anything. You have to specify everything. That's like replacing in a curse in some way, right? But once I say this is actually a variable, then it will spit out the correct answer with the parameters in the right place. Cool. So that is indefinite integrals. Now let's talk about definite integrals when you have limits. The nice thing about Sage is that you can use the exact same command and just throw the limits in. So let's say that I want to go from 0 to 1, still on the x variable from 0 to 1, and this will put in the limits, upper limit 1, lower limit 0, and you can see that is the answer. So that's how you do definite and indefinite integration in Sage. Now we can sort of play around a little bit more to see what the limits of the functionality is. Here, let me try one thing. Let's try another variable. And let's try an upper limit of that variable. I'm pretty sure this will work. So this is now integrating the same thing we had before it's a definite integral from 0 up to b. And let's see if Sage knows how to do that. No, it doesn't. See, this is telling us something. Use the assume command before evaluation may help. So it doesn't know if b is going to be negative or b is going to be 0. So let's or positive. So let's throw that in. Let's say assume that b is actually positive. It actually gave us the right answer. Cool. So this gives you an example of how you can debug things with Sage. In this case, the integral depends on whether b is positive or whether b is negative, and it told me that. That's what it said at the end there. So at the end of that error message. And so then I just said, okay, let's assume that b is actually positive, and then the integral actually works. So you do have to be careful sometimes when it gives you errors. It also gives you ways of fixing them. Let's do b is less than 0. So this is 1/2 log b squared m squared. Let's see what the difference is. In this case, it may not be any different. It is not any different. So it just had something to do with the way the integral was calculated that it needed to know whether it was greater than or less than 0. Okay, great. So that is definite and definite integrals with Sage. Just a real quick introduction to get us started with doing a lot of the stuff that we're going to have to do in physics. And this should cover us for quite a while, actually. So thanks for watching. I hope this has been helpful, and I will see you next time.